So finding the angles between two vectors. So we had two equations. We had this one, and then we had our second one, which was u1 v1 plus u2 v2. Okay, and this one we used when we were actually finding the dot product. This is the one we're going to use when we find the angle in between. What I want to actually do is take this formula here and try to simplify it a little bit better. So we're finding the angle, so let's solve for our angle. So the first thing I'm going to do is I'm going to divide off these magnitudes. And I could divide these off because they're all getting multiplied together. So I'm going to divide that to both sides. I got a little sloppy. So now I have cosine theta equals the dot product of our two vectors divided by their magnitudes, their original magnitudes. Okay? And then if I was trying to find cosine or theta, to get rid of cosine, I do the inverse. So theta equals cosine inverse of u dot product of v over the magnitude of u times the magnitude, of v. Okay? So we are going to use this formula right here to find the angle between two vectors. So all we did is we took this and we solved it for theta, because as I said, we use this one to find theta, to find the angle. So first thing I'm going to do is go ahead and find the magnitude of u and v. Or, yeah, let's go ahead and do that. So the magnitude of u is simply going to be the square root of 4 squared plus 3 squared. If you remember, if you were to draw this vector out at 4, 3, you could look at that as a triangle and you're just finding the hypotenuse. So the magnitude of u gives me 5, Pythagorean triple. Okay, and let's look at the magnitude of v. So 3 squared plus 5 squared. Okay, so 9 plus 25, so that one's going to be the square root of 34. So I've got their magnitudes figured out. So then let's go ahead and find the dot product between the two. So 4 times 3 plus 3 times 5. So I'm going to get 12 plus 15, so 27. So there is my my dot product. So my equation says 27, the dot product divided by 5 times square root of 34. Okay. Yeah, sorry, I'm going to rewrite this. So this is cosine. I'm going to rewrite this one more time. Theta equals cosine inverse of 27 over 5 square root 39. 5 times the square root of 39. And then we are going to figure what that is. Okay. So make sure your calculator is in degrees. Or technically you could have it in radians. It doesn't say if I have radians or degrees. If you are doing radians, I'd write my answer as point whatever radians. But okay, so cosine inverse of 27 divided by 5 times the square root of 39. And sorry, I don't have my normal calculator, and this is not it's not liking me. Divide. I only have my little calculator. Oops, 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 and I keep pushing the wrong buttons, and this video is getting longer. Oh, there we go. So theta equals 30.15 degrees. So the angle between those two vectors is going to be 30 point... Oh, Snapples. Guys, I need you here to tell me I'm wrong. Guess what? I put 39 and not 34, so this is wrong. Guys, it's wrong. Theta, like the setup is right, I just can't apparently write numbers. Our answer should be 22.2 degrees. Sorry, that happened. Embarrassing. I really should grab my other calculator. I'm dealing with this one and it doesn't like me. Okay, but that's what we do. Okay, on this one, let's quickly find the magnitude. And remember, this is the same thing as 2 and negative 2 in component form. So square root of 2 squared plus negative 2 squared is going to give us the magnitude of 4 plus 4, 8. So 2 square root 2. And then on this one, this is like negative 1 and negative 1. So the vector v magnitude is going to be square root of negative 1 squared plus negative 1 squared. So that's the square root of 2. Okay. And then if we find the dot product, we'd get 2 times negative 1 plus negative 2 times negative 2, which gives us negative 2 plus 2, which is 0. So I have 0 divided by 2 square root 2 times square root 2, which I don't even need to do because once I see this 0 here, I know it's just going to be 0. So I'm going to have theta equals the cosine inverse of 0. And we know cosine is 0 at 90 degrees. It's also 0 at 270, but because of that domain restriction, or you could type in your calculator, you'll get this one is at 90 degrees. Okay, so cool thing about this, if you have two vectors that are 90 degrees from each other, they are, okay, if you said perpendicular, you are correct up to a point. Okay, so I'm going to flip to the next thing. Okay, and I was going to say, any questions on this one? Not that you can ask me. I mean, you can ask me in an email, but you can't, you know, shout it out. But when we have two vectors that are perpendicular to each other, we actually call those orthogonal vectors. Okay? So everything is perpendicular except for vectors. When vectors are perpendicular, they are actually orthogonal vectors. Alright? Why not? So what we're going to do is we're going to look at these four vectors, these four pairs of vectors, and we need to decide, is vector u and vector v parallel, neither, or orthogonal? So we have a few different things. Well, we could say we know that the dot product, if the dot product equals 0, then the vectors are orthogonal. Okay, there's one way to do that, and we saw that on that last example. We could also think about this as kind of looking at them, and I want to always draw these. There's actually easier ways, but let's just kind of look at this. So we have a vector at -2, 4, somewhere over here, and then we have at 10, -20. So down here, and that is a horrible freehanding. If you look at these, what could we find with these, and what do we know about lines in parallel and perpendicular? We know slopes. So if I think about the slopes of these vectors, I should be able to identify them as orthogonal, parallel, or neither. So slope is rise over run, the change of x and the change of y. So if I want to look at these as a change of x over the change of y, we can go ahead and find the slope of each one of these. Oh, what's the word? Wow, I am struggling today. We could find the slope in between these because we have a beginning point and an ending point, right? So of this vector, I have the point 0, 0 to 2, negative 4. So slope is the change of y over the change of x. So let's say u, if I want to find the slope of vector u, I could say that is negative 2 minus 0 over, sorry, that's x. I could say it's 4 minus 0 over negative 2 minus 0. So that has a slope of 2. If I look at the other one, the slope, can you see that? Yeah, slope. Wish you couldn't see that. Awkward. The slope of vector v would be negative 20 minus 0 over 10 minus 0. So that is going to give us negative 2. And that one's also negative 2 because negative 2 minus 0 is negative 2. And you can't see that, so you... Okay? So technically these guys have the same slope. And we know if it's the same slope, it is parallel. So vector A, the two vectors in vector A, these are parallel. Okay, let's look at B. So let's find the slope. So the slope of vector u would technically 2 minus 0 over negative 1 minus 0, so negative 2 over 1. Vector v, the slope, would be 1 minus 0 over 2 minus 0 is 1/2, so these are orthogonal. Okay? I'm not going to do the other two because you guys could probably figure it out from there. So we can find the slope of these vectors, and because they're in component form, they always have a point of 0, 0. So it's really, really fast to find that slope. And if they are the same slope, parallel. If they're opposite reciprocals, orthogonal. And if they're neither of those, then they're neither parallel or orthogonal. Anyway, guys, sorry, long videos. Hope you have a great day and good luck.